All right, you've heard me mention quadratic formula several times already, and now we finally get to enter into the world of the quadratic formula. So this is the quadratic formula right here. You'll want to write this down. You'll want to memorize it. It's really important to what we're going to be doing. It's not as scary as it looks, so I don't want you to be frightened just by looking at the formula. It's mostly just a plug and chug type of thing, not a lot of thinking involved, which is sometimes fun. So the formula is x equals, this is opposite of b, or negative b. So if b is negative, we make it positive. If b is positive, we make it negative. Plus or minus, and we'll get to what that means a little bit later. The square root of b squared minus 4ac, and all of that is over 2a. So again, it looks like a lot, but we're going to kind of walk through 3 examples of how to use the quadratic formula. Even if you think you have it down after the first example that we do together, each example has a different answer. I chose them very purposefully, so make sure you kind of go through all 3 of them with me. And if you want to work ahead and check your answer, that's great too. So this is going to be our example number 1, x squared minus 5x minus 24 equals 0. So again, we want to make sure that our quadratic equals 0 before we can use the formula. And in this case, it does. We don't have to do that first step. Now, once it equals 0, we're going to pick out our a, our b, and our c. We did this while graphing as well. The reason why it was so important with graphing is because I knew it would be important later on with the quadratic formula. So if we're looking at this equation, then our a, our leading coefficient, is just a 1 because there is not a number in front of x squared, so we know it's a 1. Our b is negative 5, and our c is negative 24. So what I would do first is go ahead and plug in that a, that b, and that c everywhere where a, b, and c is in the quadratic formula. Now be really careful that we're using order of operations correctly while we do this. So it's going to take up a lot of room on your paper. Don't worry about it. It doesn't mean it's hard. It just takes a little bit of extra time. So first thing is opposite of b. So if b is negative 5, the opposite of b is positive 5. Then plus or minus the square root of b squared. So negative 5 is b, so negative 5 squared. Whenever you substitute a number for a variable, make sure you put it in parentheses, because negative 5 squared means negative 5 times negative 5, which is actually going to be a positive 25 right there. But we'll get to that in just a minute. Then minus 4, there's always a 4 right there, times a is 1, times c is negative 24. See, not so bad so far, we're just plugging and chugging. On bottom, we have 2 times a, 2 times 1. All right, now let's simplify things a little bit more. So we already talked about how negative 5 squared is 25. So now we have 5 plus or minus the square root. That's 25 minus 4 times 1 times negative 24. So I've got my calculator right here. Feel free to use one. So we have 4 times 1 times 24 is 96. So because we have a negative there and a negative there, negative times a negative will be a positive. So that's going to turn into a plus 96. The most mistakes are made right here, is knowing whether to put a minus sign or a plus sign right there. So if that would have been a positive 24, we would want a minus sign there. So just be really careful about what sign's going to go right there. And then on bottom, 2 times 1 we know is just 2. All right, now next step, what I would do is keep working underneath the square root sign. So we've got 25 plus 96. Again, calculator. 96 plus 25, 121. Good, this one's going to come out nice and pretty for us. So we have the square root of 121, which is just 11. So now we have x equals 5 plus or minus 11 over 2. Now, just like before, when we are looking at a parabola, our x-intercepts, it can just touch the x-axis and we get one answer. It can go through and come back through and get 2 answers. Or sometimes the parabola doesn't touch the x-axis at all, and then we would get no solutions. This one, most of them will have 2 solutions. It touches twice. And so we need 2 different answers here. To get the 2 different answers comes from this plus or minus sign right there. So once you get to this step, we're going to get 2 different answers. this becomes 5 plus 11 divided by 2 and 5 minus 11 divided by 2. So once you get it to this step, you're going to divide it into two different answers. So that's what the plus or minus is for. 5 plus 11 divided by 2, 5 minus 11 divided by 2. All right, so this one, we have 5 plus 11, 16, divided by 2 equals 8. So one of our answers is 8. That means if you plug 8 into that up there, you're going to get 0. All right, next one, 5 minus 11, that's negative 6, divided by 2 is negative 3. So our second answer is negative 3. That means if you plug negative 3 into those two x's, you're going to get 0. So our two answers are two x-intercepts. That means the parabola crosses the x-axis in these two places, positive 8 and negative 3. All right, we're going to move a little bit more quickly through our next two examples. So example 2 right here, you'll notice this time the quadratic equation does not equal 0, so we need to make it equal 0. My x squared is positive like we like it, so our first step needs to be to subtract the 3x to the other side and subtract the positive 3 to the other side. So we'll get x squared minus 3x minus 3 equals 0 because now nothing's left on that side. So I didn't really write out those steps, but just imagine subtracting 3x to both sides and then subtracting 3. So these cancel. We're left with 0 on that side. All right, so now we pick out our A, our B, our C. So A is 1, B is negative 3, C is negative 3. And once you define your A, B, and C, then you're ready to plug them into your quadratic formula. So again, we're going to go through this one a little bit more quickly than we did the last one. We're just plugging and chugging. So opposite of B, B is negative 3, so we put a positive 3. B squared, so B is negative 3 squared, minus 4. A is 1, C is negative 3. All over 2 times A is 1. All right, so that's what we're working with. Now we just use order of operations little by little. So I do square root everything under the square root sign first, kind of to get us going. So the 3 plus or minus negative 3 squared becomes a positive 9. Minus 4 times 1 times negative 3. I don't need a calculator for this one. If we take negative 4 times 1 times negative 3, we get positive 12. All over 2 times 1, which is 2. 9 plus 12, don't need a calculator for this one either, that's 21. So we have 3 plus or minus the square root of 21 all over 2. So now all of a sudden it became much more workable. Now, this one is a little bit different. The last one underneath the square root sign was 121, which we know off the top of our heads, the square root of that is 11, but the square root of 21 doesn't come out evenly. Now, when we get to this step, we still like to split it into two pieces, but let's go ahead and find out what the square root of 21 is. Now, when you do this, I want you to round to 2 decimals. So if we take the square root of 21, we get 4.58, and it goes on and on forever. It's an irrational number. But to 2 decimals, this is 4.58. So we have 3 plus 4.58 divided by 2, and 3 minus 4.58 divided by 2. So we're going to get 2 answers. That means that our parabola crosses the x-axis twice. So right here, 3 plus 4.58, that would be 7.58. And then when we divide that by 2, we get 3.79. So one answer is approximately 3.79. Means it's not perfect, but that's about where it crosses the x-axis. And the second one, 3 minus 4.58, is negative 1.58 divided by 2 is negative 0.79. So the second place it crosses is at approximately negative 0.79. And so those would be our 2 answers. All right, bear with me for one more example. This will be a quick one too. So here's our next quadratic. It does not equal 0, so first step is to add 1 to the other side. So now it does equal 0. then we can define our A as 5, our B as 3, and our C as 1. Once you have your A, B, and C, you're ready to plug and chug into the quadratic formula. So, opposite of B, B is 3, so that's going to be a -3. Plus or minus the square root of B squared, so 3 squared, minus 4 times A times C. So I plugged in 5 for A and 1 for C, all over 2 times A. All right, step 1. Now let's simplify the square root. So 3 squared is 9, minus, we have a -4 times 5 times 1. So that's -20, so minus 20, all over 2 times 5 is 10. So 9 minus 20, that's going to be -11. All right, now let's stop here and talk about this for a second. We got a negative number underneath the square root sign, and that's not possible. We can't take the square root of a negative number. We call those imaginary numbers, which you'll learn about in Algebra 2, but for now we will say we can stop right here. Because you can't take a square root of a negative number, this one would have no real solutions. Now, before you just, every time you get a negative under there, you jump to the conclusion that there's no real solutions, I do want you to be careful and go back and double check this part right here, because this is where the most mistakes are made. And just make sure that it really was supposed to be a -20 instead of a +20. In this case it was. We only have one minus sign, so -4 times 5 times 1. So we did everything correctly, but just always double check that step just to make sure it really should be no real solutions.